Recording in progress.
Yep. Good evening, everyone. Chalo, others, keep your cams on. There. So last class we have finished with our basic maths and vectors. Today we'll be starting with calculus. Again, another maths chapter. This is a pure maths chapter. Vectors is still fine, but quite an important one. If you're planning for advanced, without calculus, you're not be able to do any questions, and half the paper will be calculus only in advanced physics. Mains mein फिर भी ठीक है, but advanced is a different monster altogether. Again, we are going to do only whatever is required for physics. We are not going to do any high level calculus. That max people will take care of it. The only reason we are doing it because max may they will teach you calculus next year. Currently for your seniors, they're teaching calculus now. It will be too late for us by then. So I will take up from the little basic and we will focus more on the physics part of it. That is one. Second thing, I hope everyone has seen the test schedule, right? So that we will talk about that at the end of the session. I hope everyone started registering. So do register for it. Right? There'll be no OTP, nothing. Just go for that, sign up, put your email ID, put your password, and done. You are registered. I'll give you access after the class today, and then you can check it out. So let's see, end of the class, you can log in and you can check whether you got access or not. And don't worry about the timings and all. I'll let you know. I'll inform you. End of the class, we'll discuss that. So let's start off for now. And others, do keep your cams on. Tanishka, Arya, Dwight, cams on. So now in calculus, we have two parts. One is a differentiation and one is a integration. Right? Differentiation is still fine. Integration is the important one for us, but again, both are related. So before directly jumping into them, we need to define something, a function. So what is a function? I hope you studied this in school, but let's see what it means. So we write something like this: y is a function of x. So that is a mathematical symbol, y is equal to f of x. So what this means is a quantity y depends as a function of x. That is the verbal meaning of that statement. Right? So, and how do we pronounce this? We pronounce this thing as y is a function of x. That is how we pronounce that. When you say y is equal to f of x, that's what it means. And this is not new actually. You have seen this before. We just didn't know this thing. So this is how you can write. If I ask you what is volume of a sphere, what is volume of a sphere?
4
4
by
by
3
3 pi r. So the technical thing is this: volume as function of radius is 4 by 3 pi r cube. So we have supposed to write this thing as v of r is 4 by 3 pi r cube. But then again, we are lazy people, will simply say volume is 4 by 3 pi r cube. So it's like this, people call me like Arun Kumar Sana. That's my full name. No one calls me like that. People simply call Arun and you're done. Getting it? So something similar. Remember this equation? So if I say S of t is equal to ut plus half at square, you learned this in kinematics. So the meaning of this is displacement as a function of time is ut plus half at square. So we have kept on ignoring this v of r, S of t. We just directly write v is equal to 4 by 3 pi r cube. So you just need to understand, suppose if someone writes like this v of t, it means velocity as function of time t. So velocity is depending as a function of time. That is what that symbol means. That's it. So just have an idea about this. It's more of a presentation. Same thing if I write like this v of x. So velocity as a function of position or x coordinate or whatever it is. Clear with this? So what that symbol means? So if I write something like A, and if I put something in the bracket T, mean this is A depends on T. That's what it means. Is this clear, everyone?
Yes, sir.
Any doubts on this? Tanishka, clear with this? Getting it? So this is just a representation, right? It doesn't mean more than this. Example. If someone gives you y is equal to f of x is equal to x square. So basically what this means is the y is depending on x and the relation between them is x square. So if I say f of 1, so you're putting x is equal to 1, so 1 square. If I say f of 2 means you're putting 2 square, that is 4, and so on. If I take one more example, let's say if I say f of x is x cube plus x. And if I say f of 3, then it simply means x ka place mein put 3 there and 3 cube plus 3, that is 30. I hope you're getting the meaning of this. So that x is like an input, right? Yeah, x is independent and y depends on x. Suppose if I give you something like this, f of x is, let's say, x square. And let's say g of x. So g is another quantity which depends on x. Let's say 2x plus 1. Can you tell me what is this? F of g of 3. So this is a function inside a function. So think of like this. It's like an onion, okay? You have to open it from inside. First, let's see what is g of 3. So g of 3, it is 2x plus 1. So 2 into 3 plus 1, this is 7. So that means this becomes f of 7. What is f of 7? 7 square. You getting this? So there is a quantity called g, which depends on x, and there's a quantity called f, which depends on g of x. So you put g of x ka value there, and you're done. Is this making sense, everyone? So we'll have a function inside a function. Is that clear? For example, think of like this. Your position depends on speed, and your speed depends on acceleration. Agreed? If you have acceleration, your speed will increase. If you have speed, you will travel more distance. It's a function inside a function. That's it. Don't worry too much about it. This is just a basic thing. I just want you to get the terminologies right. When you hear the word function and all, in maths, you have a full chapter, they'll take care of it. But everyone got the meaning of f of x? So anytime I write f of x, it means something is depending as a function of x. If I write v of t, meaning velocity as function of time t. If I write a of x, acceleration as function of x. So some quantities depending on x and t. So that is the first thing. So just have a basic idea about what is a function. There will be no questions or anything on this, just an idea there. Great. So let's see what is differentiation. And why do we need to learn something like this? Now, differentiation and integration, right? These things are important because now till now in school, what you did, you learned stuff where things were constant. For example, think of like this. Suppose if I say a vehicle is going with a speed of 20 kilometers per hour, and if I ask you this question, after 2 hours, how much distance did it travel? What will you say? That is 20 into 2. You will simply say 40 kilometers. Straightforward, right? That was pretty easy. But what if I say something like this? But tell me one thing, in real life, when you start your scooty or your car, do you think it will go with constant speed throughout?
No, sir.
When initially your speed was 0, when you start, you go with a faster speed. At the traffic signal, you slow down. And then when the road is empty, you go fast. So speed is continuously changing at every instant. So the problem with this thing is, if your speed is changing every instant, let's say your speed is 20, the next moment it becomes 21, then speed becomes 22, then speed becomes 19, then speed becomes 21, 23, 27. How do I calculate how much did it travel in 2 hours? So the thing is, your regular max, which is there, right, is not sufficient to handle these kind of problems. You're getting it? So we need to come up with something, new or something similar to the old max, but in a different way, we have to approach this to get it. So we will talk about that. So let's start with something simple, which you already know. From there, I will try to develop the concept. So let's consider 2 points. Again, all this introduction is just for you to understand. It is really not important for physics. End of the day, what is important is there is a bunch of formulas which you need to mug up. Like I said, this is not a max class. We are a physics class. So we are only interested in the mathematical tools. And we are going to see how do we use them in physics. So just understand all this stuff. And don't worry too much about the mathematical thing there. Max may they will teach you this differentiation for 1.5 months. And we are going to do this for like 4 classes. Getting it? So consider we have 2 points. A, let the coordinates be x1, y1, and B, which is x2 and y2. So if I take the 2 points here, A, and if I take the point here, B, x2, y2, and x1, y1. Now, if I join them, I will get a line. This theta, right? If you see this horizontal distance, we'll call it delta x, which is the change in x coordinate, which is x2 minus x1. This vertical is delta y, which is y2 minus y1. Now, we learned in school tan theta is that delta y by delta x, which is y2 minus y1 by x2 minus x1. Isn't this what we call a slope? Y2 minus y1 by x2 minus x1. Did you guys study this in school? The angle made by the line with the horizontal is called slope. Getting it? But this is what we call a slope basically. So in case you don't know, so remember this. But are you getting how we got this tan theta? Tan theta opposite side by adjacent side. Opposite side is delta y, adjacent side is delta x. So this quantity is what we call a slope of a line. So we write this thing as slope of a line AB is simply change in y coordinate by change in x coordinate. So here theta is the angle made by the line with the positive x-axis. Example, suppose if you have something like this, and if someone gives you a line like this, and let's say this angle is 135, then we say slope of this line is tan theta or tan 135, which is -1. I hope this is clear, everyone, the slope part. That's the basic thing there. Great. So we know how to find slope of a line. Any doubts on this part? So if I give you 2 points, and if I ask you find the slope of a line, you know what to do. Great. So this is up to school level. Now the problem comes in real life. Does everything in a straight line? Everything is not in a straight line. Most of the times you'll find a curves. So consider a curve. Listen carefully. If you got this, this is the whole point of the differentiation there. So if you take a curve, and I took some random curve here, and if I choose 2 points now, A and B, and if I try to apply the same formula, so let the coordinates be x comma y, and let this coordinates be x plus delta x and y plus delta y. So the distance between them is delta x, and the vertical distance between them is delta y. So this distance is delta x, and this distance is delta y. Now, unfortunately, in the only formula we know is slope. So if I try to apply the formula, slope is equal to delta y by delta x. What did you actually find here? You have joined a line AB here, and you found, so this thing is slope of the line AB. But tell me one thing, does this line and this curve have any relation between them? You took a random curve, you took randomly 2 points, you joined them, and you said this is the slope. What are you even talking about, right? You have just taken randomly 2 points, you joined them and said this is the slope of the line AB. What is the relation between them? You're getting it? So this is actually useless for us. Slope of the line AB, and this has no relation to the curve. It's like when your teacher asks you, why didn't you do the homework? And you tell them natural ice cream is very tasty. You're like, what the hell are you talking, right? It's something like that. You gave me a curve and you took a line and you said there's a slope. I said, what are you even talking? So, okay. Let's say I make them little closer if delta x is smaller. So let's try to bring A and B closer. So instead of choosing points so far, bring A and B closer. Then what happens? So we have the curve. This time you brought A and B little closer. A here, B here. Then you joined a line. Still, it has no meaning. So now you take slope here, delta y by delta x. Still, there is no relation to the curve. Okay. Let's bring them more closer. Now, if you keep bringing them closer and closer and closer, so this is how we write mathematically delta x tending to 0. This is what we mean by this. This is how we pronounce it. Delta x tends to 0. Means you're bringing them so close, getting it, they're almost touching each other, right? But they're not touching. You're getting it? Basically, you're making the distance between them. Let's say one coordinate is 1, the other guy is 1.0000, something like maybe 10, 15 zeros and 1. We are talking about such a small difference. You're bringing them so close, right? They almost look like same point. A and B have almost, same. But there's a very small negligible distance between them. Then what happens? Suddenly something happens. So this curve, and you have taken A and B to be so close to each other, the A and B literally become the same point. Now, if you try to draw a line, the line AB becomes a tangent. Are you getting the story there? Again, listen what we did. You took a curve, you took randomly 2 points, you joined them. And then you try to find the line, and that is useless, right? The line has nothing to do with the curve. But when you brought the points closer, 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 and when you brought them very, very close, suddenly that same line suddenly becomes a tangent to the curve. Now, is there a relation between the line and the curve? That line is a tangent to the curve. See, I'm able to say something about the line. Is this making sense? So the thing is, making it very, very close is important. So now we say the slope. Now see how we write this thing. The slope of the tangent. We will see the practical applications also, so don't worry about it. To the curve is given by, now see, if I simply write delta y by delta x, this is wrong. I should say, mathematically, this is how they write. Limit, again, don't worry about this mathematical thing, tending to 0, delta y by delta x. What is the meaning of this statement? Listen carefully. Limit delta x tends to 0. That means the meaning of this thing is when the 2 points A and B are very, very close, then this quantity delta y by delta x becomes slope of the tangent to the curve. Are you getting how to read this thing? If I don't put this word limit here, this is wrong statement. But if I put that word limit, suddenly it becomes right. Again, see how we read this thing. Limit delta x tends to 0. That means when the distance between the 2 points A and B becomes very, very small, negligible, then this quantity delta y by delta x, it becomes slope of the tangent to the curve. Is this making sense how to read this? Any doubts on this thing? So when you brought them closer, suddenly it started making sense. Is this clear, everyone? There. So that's the thing. So we try to study it when things are very, very small. Advai.
Sir, what is exactly the slope of the tangent to the curve now? Here.
What is slope of the line? What is slope of the line? Tan
The
theta.
slope is that tan theta only. So then,
So for this curve, this theta, na?
oh, yes, sir.
You know what is the tangent to what is? I hope everyone knows what is a tangent, right?
Yes, sir.
A tangent is a point where it just that glides on that curve, it just grazes the curve. Arya.
This is the slope of the curve at that particular point, right?
Yeah, slope of the tangent to the curve at that particular point. Yeah.
So the slope will keep on changing.
Yeah, at every point you get different. Suppose if you take this A and B here, then this will be the slope.
Okay, so we just generalize it by
We are
saying
generalizing
that.
at a given point. Yeah.
So if you put some value of x, then you will get the slope
You'll
at
get
that point.
different slopes. Yes.
Yeah, okay, I got it.
But everyone got the context of it. Don't get into the mathematical part. Don't worry about like, oh, what is limit? What is delta x? What is this arrow and all? It simply means limit delta x tends to 0 means the 2 points are closer. Getting it? Exactly more details. Max may they will teach you a chapter called limits also. Right? Don't worry about it, but just understanding. Right now, all we need is understanding. Clear with this page? That is the thing. We will assume them to be very close. They're almost touching, but they're not touching. So that is an approximation we take. They are so close to each other. For an approximation, we can say they are almost same. It's like this thing, right? If I tell you to come to the class at 8 o'clock and you come to the class at 7:59, 59, it is almost close to 8 o'clock, right? So something like that. You are approximating it. That's what I'm saying, right? So differentiation, if you see, we study things at very small intervals. Now, in case you're wondering, sir, what is the use of taking such a small intervals? Let me give an example. Think of like this. Let's say you started a delivery, courier service. So you hired a person, right? And every day your job is this thing. Every day morning, 10 o'clock, let's say he leaves from Andheri and then he has to go to Kolaba, deliver a package and then come back. So first day of the job, you give him a package. He goes to Kolaba at 10 o'clock, right? And he comes back by 4 o'clock. And then you ask him, yeah, why did it take so long? Then you say, nahi sir, bahut traffic hai. Said, okay. So after a week or something, this guy goes at 10 o'clock and comes at 6 o'clock. You ask him, yaar, itna late kyun kar rahe ho? Sir, bahut traffic badh gaya, sir. There's a lot of traffic. I can't travel and everything. Now you understand, yes, there is something wrong. This guy is taking too much time and is wasting a lot of time. So what you do, you keep a tracker on his vehicle. You put a GPS tracker. And now this is what you tell the GPS tracker. Every 1 hour, send a signal where you are. Now imagine this is what you get the data on the first day. 10 o'clock is in Andheri. 11 o'clock is in Dadar. So every 1 hour it is sending a signal, right? So you don't know what is happening between. 12 o'clock, he is again in, let's say Kolaba, he has reached. We don't know exactly when did he reach, but 12 o'clock the signal is at Kolaba. 1 o'clock is at Kolaba. 2 o'clock is at Dadar. 3 o'clock is at Ghatkopar, right? And let's say 4 o'clock is coming somewhere to Andheri. 5 o'clock is in Andheri. So when he comes there, you'll ask him, right? Like, okay, what were you doing in Andheri from 4 to 5 o'clock? Sir, wo kya hai na? I was in Andheri west side. I got stuck in a traffic. It took 1 hour to come to the east side. Did you notice something here? Even though you're getting data, there is still some problem here. But what if you tell the GPS tracker, give me a signal every 5 minutes? Now, what do you think will happen? We'll get more precise data. 10 o'clock is in Andheri, right? 10:05 is somewhere there. 10:30 is in Dadar. 10:45 Dadar. 11 o'clock Dadar. 11:30 is in Dadar. 12 o'clock is in Kolaba, right? Then if you see, right, maybe 3 o'clock you reached in Ghatkopar. Now you get exactly data there. You ask him, you reached Dadar at 10:30. What the hell are you doing till 12 o'clock? You're getting it? So when you start taking more and more data points, you actually get more precise data. Is this making sense? But the problem with this is what? if you take data, if you ask the GPS to send a signal every, minute or every 5 minutes, the battery will get exhausted. So there is a limit. How much data can you take? You're getting it? Let me give you one more example. This is something which you actually use every day. Ever heard these words analog and digital? You know, what does it mean? Analog and digital, you must have heard about it a lot. So currently, right? No, it's not type of things. And think of like this. Let's say when you're playing an instrument or when you're music or something, let's say now when I'm talking to you, what do you think is happening? So when I'm speaking, this is what is happening. My voice is actually a bunch of signals. Getting it? Let's say some voltage signal or something. So this is my voice ka signal. Let's say voltage versus time. So when I'm talking into a speaker, the problem with the speaker, right? It cannot choose all the data points. You know what it does? This is what happens with your music. The system, whatever I'm speaking into, it takes few data points. Did you guys ever see this thing on an MP3 file here? 128 kbps, 320 kbps. Did you guys ever see this thing at the end of the file ka name?
Yes, sir.
If you ever download music, right? I don't know, so everyone uses YouTube and everything. But once upon a time, we used to download music into this player and everything. You will see a file ka name like this, 128 kbps. What is the meaning of this thing is 128 kilobytes per second. So what your computer does, so think of like this. So this is my analog signal. So I'm just speaking, this is my analog signal. I have signal at every point of time. So I will tell my computer, boss, record my voice at a rate of 1 bit per second. You know what it does? Every 1 second, it will take one sample and it will try to plot it on a graph. And this is how the graph will look like. Every 1 second, it will take a signal. And now if I tell the computer to play the signal, you know what it will play? This is what it plays. For 1 second, it will just play that one signal. And this is how my voice will come. You getting what is happening? Whatever sample it took, it will play it for 1 second. It will take the next sample, play it for 1 second, and so on. You will not hear anything. It will be all garbage. So then you will say, okay, computer, record 10 bits per second. Means you're telling for every 0.1 second, collect a signal. Now, if you try to do the same thing, now the signals are a little more closer. Now, when it joins, you might hear my voice little better. So when you say 128 kbps, you're telling the system collect 128,000 samples every second. You're getting the meaning of this? So when you take so many samples there, and if you try to join them, then the signal starts coming closer to a curve. What do you mean by 320 kbps? You're telling your computer to record 320,000 samples every second. Aditi, you're getting that? Whatever you're speaking, right? You're telling your computer when I say 10 bits per second, means you're counting, you're taking one sample every 0.1 second, you're taking a sample. You're getting it? So is this thing looking confusing, everyone? You're getting how
No,
a computer records your voice?
Yes, sir.
Currently, see, now when I'm speaking, think of like this thing. Let's say I'm singing a song like this. Let's say I'm singing something like, sa, re, ga, ma, like this, I'm stretching each one, let's say for 1 second. Now, if I tell the computer, record a sample every 2 seconds, you know what it will record? It will record sa, it will not record re, it will record ga, it will not record this, it will record this. You're getting it? It will record a sample every 2 seconds. So when I tell it to play, what it will play? Sa for 2 seconds, ga for 2 seconds. It will not play re in the middle. Are you getting it?
Yes, sir.
So every second, if for example, think of like this. If I say, let's say I'm counting numbers 1, 2, 3, 4, 5. I'm counting one number 1 second. If I tell the computer, boss, record at a rate of, half bit per second. it will count 1, 3, 5, 7. It will not count the even numbers. Is that making sense? So what your computer does is this. It takes a curve, which is your voice or anything. It takes a lot of samples on it. It will try to replicate the same thing. But your computer doesn't know how to draw a curve, so it will draw straight lines. And these lines are so close, you will think it's a curve. And the best example, did you ever see a circle on a computer screen?
Yes.
You have never seen one. You have never seen one. You have never seen a computer on a circle on a computer screen. For example, do you think this is a curve? If I actually zoom in, can you see the pixels? So when I tell the computer to draw a curve, you know what it is doing? All these pixels which are there, computer doesn't know what is a curve. It is just joining these lines. And the pixels are so small, you think it's a curve. Did you ever play Snake game on Nokia mobile? How does the snake look like? It looks like rectangle, right? So basically each one is a pixel. Your Nokia ka snake is a pixelated snake. So if you take your smartphone or if you take your photograph and if you zoom really in, you will see actually pixels. So when you tell a computer boss draw a circle, you know what it is trying to do? So when you ask a computer to draw a circle, if you actually zoom into this, the computer is actually drawing straight lines like this. It's not a circle. Did you ever see, you know, in the local railway station ka timer how it looks? How does the 8 look like? 8 looks like this, right? You can't draw a curve. If you ask a computer to draw a circle here, you know what it will do? It will join these two lines. And it will say, boss, this is your circle. The more pixels you have, the more closer you get. So on your smartphones, this is what you have, the DPI. I think DPI or PPS or something abbreviation. The number of pixel density, basically. The more pixels you have, the more screen looks. Anyway, so that is a basic thing. So every time I'm talking to you, actually, you're using calculus. So when I'm speaking to you, my earphones, whatever is there, are recording my voice. They're collecting at a rate and they're sending into voltage signals. They're coming to your speaker and then you're getting a voice. So there is actually some information which is missing. Did you ever buy a audio CD? You must not be even having it. Next time, try to go to a shop or best example. Ever took a photo with your DSLR camera? And then did you ever try to send that photo in WhatsApp and then download? Photo becomes completely pixelated. Ever observed? You don't get the clarity. Because what WhatsApp does, if the file size is 10 MB, it becomes too much. It compresses the file, something like, you know, maybe half MB or something, and then it's easy to transfer. So, you know, how does it do that? So in that photograph, whatever pixels you have, what WhatsApp does, it removes some of the pixels. So when you see from far, the picture looks the same, but when you zoom in, you can't see the picture clearly. It becomes pixelated. So when you remove the pixels, you can save data, so the file size becomes smaller. That's what happens whenever you do compression. You lose information. So things like this. So when you're doing into computer programming, right, these are all the stuff that you will be learning. Compression algorithms and all that stuff. It's not about going in there and typing keys. Till school, you must have thought computer science matlab go there, put syntax, put comma, put column. So that is not computer science. Aditi, bolo no.
Sir, so basically the graph that we're drawing of the slope of this limit, it's just a really zoomed out graph of the 2 points. So it looks like one.
Yeah, line. Yep, right.
Yeah, okay. So you could just say that, sir.
No, okay, but you got the idea there.
Yeah,
No, you need to know why you're learning this thing. But everyone got an idea? So there. So think about that. Whenever you're talking about, you know, this audio, analog, digital, your speaking voice, all this is all based on this only. Anyways, so that is one. Now see, because I can simply give you formulas and you'll say, remember this, but better you have a little idea. What is the point of just mugging up without even knowing what you're going to use it for? See, now you know at least your whole life you have never seen a circle on a screen. See, now you know at least your life is a lie. Did you ever actually hear your own voice? Did you ever actually hear your voice? You should try this. Maybe after the class, right? Take your phone, record your voice and hear it. And you will say, this is not me. And take that recording and give it to your mom and ask her, is this my voice? She will say, this is you only, you are speaking. Did you ever notice that? When you hear your own voice, it feels like so weird. It feels like, who the hell is this? Ever thought about it, why it happens? You should definitely try that answer. Your voice will feel so weird. When you're speaking, right, it feels like your voice is sweet and beautiful. But when you record and hear, it feels like horrible. Arya.
That's because the computer cannot pick up enough data points, right?
No, it's not about that.
Then why does it sound different?
That's what I'm asking. What do you guys think? The thing is, see, when I'm speaking to you, how is the sound coming to you? From my mouth, through the air, to your ear, isn't it? But when you're speaking, the voice which you're hearing is coming through your cheekbones. You actually hear two sounds. One sound comes through the air and one sound goes through your cheekbones. And sound travels faster in solids. So you're actually hearing two sounds with a small time gap. So you know what my brain actually hears now? When I say hi, it hears hi, hi. Hello, hello, hello. How are you? It hears two sounds every time. One sound is coming through air and one sound is going through the bone, and there's a time difference. You will go mad. So what your brain does, it takes both the sounds and does a remix and makes you listen something else. That's not your voice. So right now when I'm speaking and what I'm listening and what you're listening are two different sounds. My voice looks pleasant to me, but for you it might look like someone kept stones in a. Ever seen this thing people sing in bathroom? Or your friend is singing a song. He's like, yeah, oh, and you're like, why is this guy shouting like a fox or something? But that guy feels like he's singing very beautifully. Ever felt? When you sing, your voice always feels beautiful. But the people beside you are going mad, like, what the hell are you doing? So the thing is, you have never seen a circle in your life. You never heard your own voice in your life. See, your whole life, life was a lie. If you think about it. Why all that? Did you ever see a photograph? It looks weird. If you ever see your own photograph, it looks weird. You know why? We are used to seeing ourselves in mirror, and in mirror, left and right are interchanged. So when someone suddenly takes your photograph, you know it is you, but it feels little weird. Because we humans, right, our faces are not symmetric. One eye is little big, one eye is little small. Maybe one side it is little more shaded, one side there is a pimple. So the photo looks little weird. Something got mixed up here. Yeah, but Samsung does something. It has a feature which will actually shift the photo and give you. Nowadays, we got that features also. So even your own photographs look weird to yourself. So yeah, so if you actually start observing things, you will learn a lot of stuff. Anyways, let's get back to calculus. Now, getting to this. So this is how we write this. Limit delta x tends to 0. So the meaning of this is the 2 points are very close. Delta y by delta x. So this is the meaning of slope. So slope of the 2 points when they're very close. This is slope of the tangent to the curve. And physics people are lazy. Who will write this such a big term every time? Slope, limit, delta, y by delta, x and everything. So we said, let's do something nice. So we simply say slope, limit, delta x tends to 0, delta y by delta x. We will simply write this thing as dy by dx. You're getting at all this thing, I will just replace this with one term called dy by dx. What is the meaning of d? Delta means change. D means very small change. So theoretically, they're the same thing, but we are talking about very small change. Just to give an example, if someone says delta x, we are saying something like 2, 4, maybe 0.1, something like this. But the moment you say dx, I'm assuming you're talking about something like this. They're talking about something like that. When you say dx, we're talking about such a small quantity. You can put 100 more zeros if you want. You're talking about such a small quantity. Clear with this? And be careful, don't cancel this d and this d. Kidding? And those are d's are not alphabets. So this thing d by dx, this is called a differential operator. So that whole thing is one term here. D and D are not symbols, don't cancel them. So what does this do? See, operators, right? If you see plus, minus, plus is an addition operator, division is an operator, multiplication is an operator. So if I say 2 plus 3, the plus adds 2 and 3. That is the meaning of it. It does an operation there. Getting it? Now see, if I write 2 plus 3 by 3 plus 5, if I cancel this plus and this plus, and if I say this is 23 by 35, what do you think? Looks really weird, right? You feel like, so what the hell are you talking about? So if you cancel this d and this d, I will think the same way. Clear with that? So don't cancel the d and d. Medical people do that. You guys are not supposed to do it. Okay. So what it does, this thing compares. So whatever quantity is there, it compares with x. But for now, keep it simple. Don't worry too much about it. Clear with this? So all the story, right, is to tell you what is this dy by dx. If we say this thing, y is differentiated with respect to x. So how do we calculate this actually? Like I said, again, this is not important for physics part, only the result, but I'll show you one. Max they will teach you this. So when we calculate this, I think we'll not do that also. It is pointless. So just have an idea about this differential there. So let me show you a few examples there. So if I give you a quantity like this, dx by dt, x is position, t is time. So even though I showed you dy by dx, right? See, I showed you dy by dx because you know what is the slope already. But in real life, you can actually compare any quantity with any other quantity. Tell me what is position by time? Velocity, right?
Speed or velocity.
Yeah, so we'll take it as velocity here. So change in position by change in time. That is the meaning of it. Dx, change in position, dt, change in time. Change in position by change in time is velocity. So if you write dv by dt, acceleration, velocity by change in velocity by change in time. So basically you can compare any quantity with any other quantity. You will even see quantities like this, dt by dx. T is temperature. X is position. This is called temperature gradient. So later on in physics, right, you will keep hearing terms like this, dt by dx, dx by dt, dv by dt. So don't get scared. What it means is simply you're doing change in velocity by change in time. Suppose if I do dw by dt, where w is work. What is work by time? Power. Clear with us? So you will keep seeing quantities like this. So this dx by dt is called a differential. So what does differential give you? It simply tells you the change in this quantity x with respect to time. Suppose if you are comparing change in y coordinate with change in x coordinate, it is called slope. Understand this. If you are comparing change in y coordinate with change in x coordinate, it is called slope. If you are comparing change in x coordinate with time, we call it velocity. If you compare change in velocity with time, we call it acceleration. If you compare change in work with time, we call it power. So depending on which quantity you are comparing with what quantity, you will get different things. Is everyone clear with the understanding part? Don't get into the mathematical part. Just try to understand what does dy by dx mean? What does dx by dt mean? Clear with this?
Yes, sir.
Now we have a simple symbolic representation. D by dx of f of x. So this is the differential. You're comparing f of x with d of x. Again, we are lazy people who will write such a big thing every time. So we'll put f dash x. So if you put a dash on the top, it's called a first differential. Don't worry about this. We will see a lot of examples. You'll get the hang of it. It's actually easy only once you remember the formulas. It's called first differential. What if you differentiate the differential again? D of x, f of x. So differentiate once, differentiate twice. Then this is written as d square f of x by dx square. This is how they represent it. This is written as f double dash x. This is called second differential. You have differentiated a quantity 2 times. This is not new. See, if you differentiate position with time, I'll get velocity. If I differentiate velocity with time, I'll get acceleration. So if you differentiate position 2 times, you get an acceleration. So eventually, if you simply write d of dx power n, dn f of x, this thing is simply written as fnx. This is called nth differential. Don't worry about this. After doing examples, you'll understand the meaning of this. But this is just a symbolic, representation you need to know. First differential, second differential, and so on. So whatever we did till now, it is just a basic introduction. It's okay if you really, didn't understand the symbolism mathematical part, but just have an idea what it means. Now, after this, what we are going to do is more important for physics part. So differentiation, we have 3 levels. One is a basic one. The second thing is some relations between them. Third one is a chain rule. That is the most important one. If you know these 3 levels of differentiation, you'll be able to handle most of it. So let's see the formulas first of all. So you can actually write them down. It will be useful. So we have a quantity f of x. So listen, I'll just explain you a few things. So I'll give you a function here and I'll give you the answer here. How did we get this? We are not interested. So we will just mug it up. So the first one, if you give me a constant and if you differentiate. So if you differentiate a constant, again, try to understand the meaning of it. When you say dA by dx, you are asking change in A with respect to x. Does a constant change? No, therefore it is 0. So if you differentiate a constant, you will get 0. Example, if you say d by dx of 23, 0. If you say d pi by dx, pi is also constant, 0. If you differentiate a number, it is 0. That's your first formula. If you differentiate a number, you get 0. X power n. So if you differentiate x power n, the formula is given by n into x power n minus 1. Example, if I say differentiate x cube, look at the formula. In the place of n, we have 3. So this has to be written as n into, that is 3 into x power n minus 1, 3 minus 1. This is 3x square. Let me take one more example. If I say d by dx of root x, root x is nothing but x power half. So n ka place mein we have half. So this is half into x power half minus 1. So this is half into x power minus half or 1 by 2 root x. There. I think you can copy down these formulas. This is 1 and this is 1. How did we get this? We will not do that. Max people will teach you. But you should know this formulas. If you differentiate x power n, that after differential, it will become n into x power n minus 1. Put it down. You will need that. We will see a lot of examples, so you will need it.
Sir, when will the coaching classes general take the calculus part in math?
Next year, well, standard this time. For your
Yeah,
seniors,
sir,
currently
till
they're
then,
doing it
what do
now.
they do?
I don't know. You should ask your maths teacher. You're asking the wrong teacher.
Like, what do they do generally before
Ask your
calculus?
maths teacher, Nare. How will I know what they will do? They have a lot of chapters to do. They have trigonometry. Normally, people start with trigonometry.
Sir, I mean, are there any prerequisites for the calculus, like for
Yeah,
it to
you're
understand?
asking. There's nothing there. You should ask your max teacher. Like I said, we are not interested in how these things came. We are just interested in the results. You will see applications. We are more interested in applications. Copied, everyone? Next one. So if you give me a function sin x, so if you differentiate sin x, you will get cos x. If the function is cos x, if you differentiate cos x, you will get minus sin x. You should definitely mug up these results. If you differentiate tan x, you will prove tan x later on. You will get secant square x, but it comes a lot, so I'm giving it. E power x. So e power x ka differential is e power x. So what is this e exactly? E is called exponential. Just like pi is a number, e is also a number, 2.713 approximately. So just like pi has an importance, e also has a lot of importance. So you will learn this thing in logs. That is one thing. Again, max they should teach you logarithms. By any chance, you guys know about logarithms? Everyone knows about logs? Anyone who doesn't know anything about logarithms? Everyone has an idea about logs, right? A bit of it. So we will see later on. But for now, just take it from me. So when you say ln x karke, what it means is log to the base x. So there's something like that. So if you have ln x, that's how we pronounce it, ln x. So d by dx of ln x is 1 by x. A power x. This eighth one will never come in physics, but sometimes you might see them just giving it. A power x ln a. There, up to 7. These are the main results you need to remember. In max, they will teach you more deadly ones. These are like, think of like this. This is like a small puppy on a road. Max, they'll teach you Godzilla. So these are nothing. The calculus in physics is like you will feel very good about it next year. Once they actually teach you in max, you will cry. But it has a pretty high weightage in max. Put on the results, you'll need them. This is the first level. There is no reason why we got them. You should know the results. This is level 1 of differentiation. Arya, got something?
सर ये ई का लाइक सिग्निफिकेंस क्या है और हम उसको रेस करने के बाद वो वही क्यों रहता है?
Max will tell you.
Sir, at least some explanation, sir.
That's a very special curve, right? मतलब सोचो ना, the slope of that is a curve itself.
At all points.
At all points.
Okay.
No, why मतलब है max में ऐसा curve है, अभी क्या करेंगे ना?
I mean, there should exist like so that
something
is
will
e.
exist. That is e power x.
Okay, all right, I get it.
Copied, everyone? Max people should start teaching you logarithms also soon. So clear? Sudiksha, clear? Ashvi, go ahead. This is one level. Second level, we have some identities. First one, suppose if you differentiate a function a into f of x, meaning you have a function with a constant inside. I'll give an example. So what happens is the constant comes out. Look at this example. So if you ask me to differentiate d by dx of 3 into x square, first of all, 3 is a number, 3 comes out. Then we have dx square by dx. This thing looks like which formula? This thing looks like the second one, right? it looks like x power n, where n is equal to 2. So what is the formula for x power n? N into x power n minus 1. This will be 6 into x. Got what we did there? Let me show you one more example. Let's say if I say d by dx of 5 sine x, let's say 5 cos x. 5 is a number, it comes out. Then it will be d by dx of cos x. Cos x ka differential is minus sine x. So this will become minus 5 sine x. You're getting this? So if you have a number into a function, push the number outside and just differentiate. Second thing, if you have d by dx of f of x plus or minus g of x, that means if you have two functions subtracted or added, and if you try to differentiate them, then this guy will become simply d by dx of f of x plus or minus d by dx of g of x. You just differentiate both the functions separately. Example, if you say d by dx of x cubed plus x, then this can be written as dx cubed by dx, dx by dx. You can clearly see here, this guy is n is equal to 3, this guy is n is equal to 1. So apply the formula, 3 into x power 3 minus 1. I'm using x power n ka formula. This is 1 into x power 1 minus 1. This is 3 into x square plus x power 0, which is 3x square plus 1. So basically dx by dx is 1. You can clearly see.
Sir,
Yeah.
in the first one, a आपने constant बोला पर constant तो 0 होगा ना?
नहीं, अगर if you differentiate only constant 0 होगा ना, it is a constant into a function.
Oh, okay. तो वो कुछ change नहीं होगा उसमें.
नहीं, constant बाहर आ जाएगा, function will differentiate as usual. Put on these two formulas, everyone.
Sir, can you show the last slide, please?
Copied? Next one. I know we have a little more theory. We'll see applications, that will be fun. But we need to get the basics right. Second one, see now, if you have two functions, f of x, g of x, then what you do, just differentiate them separately and then just add them or subtract them. For example, look at here, x cube plus x now. So there are two functions, right? So what this formula says is differentiate x cube separately, differentiate x separately, and then just add them up. So are you confused with this separation or are you confused with this one? Now you got it, no? Clear, everyone? Third one, important one, comes a lot. D by dx of f of x into g of x. What if two functions are multiplied? This is called product rule. So this is a solution for it. So g of x, so differentiate one function and push the other one outside. Then push f of x outside and then differentiate g of x. Let me take an example. Let's say d by dx of, let's say someone gives you like this, x square into sine x. Look at this, there are two functions here. X square is one function. Sine of x is another function. Now, according to this formula, g of x will come outside. Then you differentiate f of x, which is x square here, plus x square will come outside and then differentiate sine x here. Then you go back to level 1 and look at the formulas. Sin x, what is x square? N is equal to 2. So 2 into x power 2 minus 1 plus x square. Sin ka differential is cos x. So this will be 2x sin x plus x square cos x. Have a look at the example. The best way to learn is examples only. The formula will look really weird. F of x, g of x will feel like what the hell. But I hope the example is clear. If there are two functions multiplied, differentiate one, push the other one outside, and then for the second part. Have a look at this. Ask me if you're confused. We will do a lot of problems now. Don't worry about this. Clear with this? Can I go ahead? Clear now, Arya?
Yes.
The fourth one is the division rule. D by dx of f of x by Advai.
Can you please switch to the previous slide for a few things? Even this one's previous now.
Oh, Pete, क्यों copy नहीं किया? And what were you doing till now? मैं हर पेज टर्न करने को पूछ रहा हूँ ना. It is done, then say something ना then. Clear? Next thing. Just put on the main thing. That's it. Only these formulas. After that, there's no need to copy the notes. So the formula for this thing is g of x differential of f of x, then f of x, and then differential of g of x. G of x ka whole square. I think out of all, this is a little bad one. Example. Let's say d by dx of tan x. So we can write tan x as sin x by cos x. So these are the two functions. So f of x, so that is one function. G of x is another function. That is the meaning of f of x and g of x. There are two different functions. Now try to put that in the formula. G of x, so g of x is cos x. Then you differentiate f of x, which is sin x, minus f of x is sin x, then differentiate cos x. And then the denominator is g of x ka square, which is cos x ka square. What is sin ka differential? Cos x. What is cos ka differential? Minus sin x. So numerator becomes cos square x plus sin square x, which is 1. And 1 by cos x is secant square x. That is how we got the formula. Clear with this. This is level 2. So if you know these 4 identities, and if you know the first that 7 formulas, I think you know a lot of them. We can do some applications on this. But before applications, let's see some practice problems. But have a look at this. There's a third level called chain rule that we'll see later on. In the next class, we will do that. After that, we have something called maxima, minima applications. These are some really good questions. But your basics must be clear. Any doubts on this, ask me. But let's see some problems. I think that is the best way to get a practice. These things, when you look at them, they'll feel a little overwhelming. Only when you do little practice, you'll get the hang of it. Clear, na, Trishi? Siddesh? Ananya, clear so far? Devanshi? Advait? Shreyan? Utsa, clear? Go ahead. Advait?
Yes, sir.
Great. Let's see some problems. So I'll give you the functions, you guys differentiate. I'll give you the answers, then you can check. That's the best way to do. Again, don't think too much. Whatever formula you think, just put it there. You have a formula that you can refer. So d by dx of, let's say, x power 4. Don't write the question, just directly solve it. Let's get them out. Right, most of you are getting it. Get them. I think for some of you, the chapter is over. They look easy, but if you have not done this before, let's get this thing. It's okay. Don't type the answers. You can just finish it off. I'll show you the answers, then you can verify whether you got it right or not. Hmm. Let's see. Check your answers for the first 5. This will be n is equal to 4. So the formula is 4 into x power 4 minus 1. 4x cubed. This is n is equal to 3 by 2. So 3 by 2 into x power 3 by 2 minus 1. 3 by 2 root x. That is x power half. This is this can be written as, I shouldn't have erased the other one, no? Okay. D by x of x power minus half. So n is minus half. So this is minus half x power minus half minus 1 by 2 into x power 3 by 2. N is minus 5 by 2. This is minus 5 by 2 x power 7 by 2. Sine ka differential is cos x. Cos ka differential is sin x. Are the answers clear, everyone? Anyone not clear with any of these five, please ask.
So, in the fourth one, I'm not
Mhm.
correct.
This thing is what? X power minus 5 by 2 minus 1, na? So minus 5 by 2, x power minus 7 by 2. Minus will go down, so it will become x power 2
Okay, thank you.
by 2. Get the remaining of these things? I'll send you a small sheet on this thing, so definitely make sure to practice this before the next class. They're not tough, you just need little practice, you'll get speed. Get them, I'll give 2-3 minutes. These are a little more complex.
Sir,
Hmm.
can you show the solution of the first one?
It is f of x plus g of x, no?
Yes, sir.
So differentiate sin x cos x आएगा, differentiate cos x minus sin x आएगा. Just add them. Anyone confused from 1 to 5, please ask, get it cleared. Did everyone figure out what the sixth one? Tanishka done? Okay. Others. What is the sixth one? This is f of x plus g of x. See, there are two functions you're adding. So this can be written as d by dx of x cube plus d by dx of 2 into x. X cube ka differential is n is equal to 3. So 3 into x power 3 minus 1 plus 2 will come outside. This will be dx by dx. This is 3x square plus 2. Getting this, I will start skipping steps slowly now. How to do this thing then? Later on, you will learn there's something called chain rule that will make your life easy. But for now, we don't know chain rule, so we will just expand this. D by dx, this is like a plus b whole square, x power 4 plus You guys are able to hear me?
Yes, sir.
I can't see you. My power is lost here.
Recording in progress. Recording in progress.
Yeah. Hello.
Yes, sir.
Yes, sir.
Chalo. Uh, why am I hearing my voice 2 times? Yeah, chalo. Let's see now. You guys are able to see the screen, right? Chalo. Let's get then. What is the next one gonna answer? I can't see you, any of you. You guys are keeping your cams on? I still didn't get this power. I'm trying to see something on my phone. Okay, let it be. At least we have some internet. We have battery also. It should work out. So let's see the second one. So this thing you can just expand a plus b whole square, and then if you try to solve, this is d by dx of x power 4 plus 4 into d by dx of x square plus d by dx of 4. How much is this? This will be 4x cubed plus 4 into 2x plus 0. This is 4x cubed plus 8x. Hey everyone. Do I see you guys on this Chota screen?
Sir,
How did we get 4x cube plus 4 into 2x plus 0?
This thing, look at this thing now. So this thing is clear. Now x power 4 is how much? This is n is equal to 4. So that will be 4 into x power 4 minus 1. What is x square? This thing is n is equal to 2. So that will be 2 into x into 2 power minus 1. So that is 2x. And 4 is a number, so that becomes 0.
Okay, thank you.
Sure. The next one. Yeah, struggling a bit, guys. So there is no power. This thing looks so messed up. I'm not gonna the power restore. Okay. Let's see the remaining ones. But any doubts on 7 and 8, please ask. How to do sine square x and cos square x?
Sir, product rule.
Yep, we use the product rule. When you guys are talking, right, then your picture is coming on my phone. How can I see you guys on my phone? These things I need to experiment once. Okay, let's see the product rule here. So this guy will be dy by dx. So you write this as sine x into sine x. Later on, I'll teach you something called chain rule. This will make things much easier. So this is f of x into g of x. Then remember the product rule. So put one quantity outside, the differentiate the other guy, and put the other one outside, and then differentiate the first one. So using this formula here, so put sine x outside, differentiate sine x. Then the other one again, sine x outside, differentiate the other one. Sine ka differential is cos x. So this will give you 2 times sine x cos x. And I hope you remember sine a cos a, 2 sine a cos a is what? Sine 2a. This will become sine of 2x. Have a look at this. Same thing, can you do for cos square x also? Try, I'll give another minute. So you use the same thing, chain rule. Get it, I'll give you 30 seconds for cos square x. If you type your answers, I can't see your answers, right? Ha, I can see you guys. I did something with the phone. I can see only 8 of you. How to do for cos square x? The right one, Shika, you got it. I can see your messages also. So let's just expand this, d by dx of cos x into cos x. Again, same story. This is f of x. This is g of x. So put one cos x outside. This is not physics. This is the brute force max we are doing. So yeah. Cos ka differential is minus sin x. This will be minus 2 times sin x cos x, which is minus sin 2x. There, this is how you use it. Any doubts up to 9, please ask me. Any issues, any queries, you can just unmute and ask. I can hear you, but I can't see your messages. So Any doubts on this up to 9? Then just finish off the last two. Those are the easy ones.
Sir,
Yeah.
so can we say 1 minus cos 2x upon 2 differentiation is sin 2x?
Yes.
Okay. Sir, so is there any relation as such?
There is a relation. वो बोल रहा हूँ ना, वो third level था, chain rule का we use that, so we'll get it there.
Okay.
I'll teach you that. So this thing, right? The f of x, g of x. So there are 4 functions. You can just expand all of them. So d by dx of e power x, d by dx of ln x, dx by dx plus dx by sin x. So e power x is e power x, ln x is 1 by x, dx by dx is 1, sin x is cos x. Right? And what about this guy? E power 2x is nothing but e power x into e power x. Again, product rule, f of x into g of x, e power x into differential of e power x, e power x का differential is e power x only. This is 2 times e power 2x. Check. Any doubts on 1 to 11? Please ask. Clear? Great. Let's see some applications. Any doubts on this? Great. Let's see a question. Now, how they'll ask you in physics? They'll not ask you like this. They'll never give you a function and ask you what is the differential and everything. So let me give you a scenario, and then from there we will take it ahead. So let's say we have a plane here. Whose curve is y is equal to x cube. Let's say this is 0, 0. Let me start with something simple, and then we will go ahead with this. So let's say we have a curve like this. Let's say this is y is equal to x power 4. Okay. First question. Find slope of the tangent x is equal to 1. Second question. Find the coordinates of the point where slope is equal to 16. There, let's get these two.
Or could you repeat the question?
So we got a curve here, y is equal to x power 4. This is the curve, the equation of that. So the first question is find the slope of the tangent at x is equal to 1. So if you take a point here, x is equal to 1, at this point, if you draw a tangent, what is the slope?
Okay. Got it.
You're getting it. Second question. The slope of the tangent is 16, then what is that point?
All right. Thank you.
Hmm. Yeah, I'm back online. How do we do this?
Sir, is my answer correct?
Let's see. Again, listen, everyone. Let me help you with one. What is the question? Find the slope of the tangent. So what is the slope? Slope is nothing but dy by dx. Does everyone agree with this? Isn't that what we did the whole thing about? Dy by dx is slope. But what is dy by dx? Y is given as x power 4. So d by dx into x power 4, which is here n is equal to 4. So apply your formula x power n, 4 into x power 4 minus 1, 4x cubed. So indirectly what we got is the slope is 4x cubed. What does that even mean? What it means is, if you take any random point here, any point here, and if you try to draw a tangent, where the coordinates are x comma y and this angle is theta, so he is saying the slope here tan theta is 4x cubed. Is that making sense? Because look at this thing now, for this line, this is the tangent here, this is the tangent here, this is the tangent. Can you see every point the slope is different? The line is making different angles.
Yes, sir.
We get different tangents there. So for the first question you are asking, what is the slope of the tangent at x is equal to 1? So x is equal to 1, the slope, which is 4x cube, will be 4. The second question, if the slope is 16, what is the x coordinate? If slope is 16, which is 4x cube, that means x cube is equal to 4, that means x is equal to 4 to the power of 1 by 3. Is this understood, everyone? There, that is what it means. When you say I'm differentiating a function x power n, you're actually finding the slope for a tangent for that particular curve. That is what it means. Is this clear, everyone? Clear, na, Ashwi?
Yes, sir.
Now let's see how they'll ask in the exam. No one will ask you like this in the exam. Let's say we have a mirror here. Whose equation is y is equal to x square. This is basically a parabola. You got a mirror like this. This is your x-axis and this is your y-axis. This point is your origin. Now what happened? Someone sent a light ray. This is a horizontal light ray parallel to x-axis. this thing hits the mirror and then it becomes vertical. Now, do you think this will happen everywhere? For example, think about it. If I send a light ray here, it will become like this. If you send a light ray here, it will become like this. If you send a light ray here, it will become like this. You're getting how it is? So depending on where you're sending a light ray, it will reflect in different way. But there is one special light ray where if you send it, it becomes exactly 90 degrees. Find the coordinates of point P. Give it a try. I'll explain you this and then I'll give you one more like this. But are you getting what is the question? So we have a parabolic mirror. So it's not a plane mirror, it's a curved mirror. So y is equal to x square is a parabola. So that is the shape. So when a light ray hits a particular point on this mirror, it becomes vertically. It becomes horizontal, becomes vertical. What is the coordinates of that point P? Anyone who didn't understand the question, please ask me. Question is clear, don't know what to do, that's a different story. Try for a minute. Right, Samyak, you got it.
Sir,
So
where
this is
do
how
I
questions will
message
be.
you?
You can message I'm back, co-host.
Sir, but the coast account is not there.
I'm not there. I'm not there.
Recording in progress.
No worry, I need to check your answer. I lost power again. Something is going wrong right today. We are not having a good day. Anyone else got an answer for this? Let me show you this. Listen carefully. I'll give you one more like this. So we have to actually use a bit of ray optics. I hope everyone knows this concept, right? The angle of incidence is equal to the angle of reflection. So for this mirror, if you draw a line, this will be your normal. And for the normal, if you drop a perpendicular, that will be your tangent. Is this clear, everyone? That's your normal and this is your tangent. Now we know from principle of reflection, angle of incidence is equal to angle of reflection. That means if this angle is 45, this angle is also 45. Everyone agrees with that? And if that is 45, and we know these two angles is 90 degrees, so this also has to be 45. If that is 45, then the tangent here will make 45. So therefore, the tangent makes 45 degrees with x-axis. Anyone not convinced with this, please ask me. Therefore, the slope of this tangent is tan 45. That is the definition of a slope, tan of the angle made by the x-axis, which is 1. But we also know from calculus, slope of the tangent is dy by dx, which is d of x square by dx, which is 2 into x. But you're telling me the slope is nothing but 1. Therefore, x is equal to half. And if x is equal to half, you can substitute in y is equal to x square. This will be 1 by 4. Therefore, the coordinates of point P must be half comma 1 by 4. Is this making sense, everyone? So we actually have to use ray optics, the principle of reflection, from there get the slope, and then use calculus to equate them both. So if you see, the differentiation is very easy. X power n ka differential simple formula. But no one will ask you what is the differential. The question will be mixed up like this. Any doubts on this? Ovia, clear with this?
So, how did you get tangent makes 45 degrees with x-axis?
ये देखो ना, this thing. This was the light ray. तो ये 90 है ना? This is the normal.
Yes.
ये angle equal होना चाहिए.
Yes.
So that is 45 and 45.
Yes, got that.
So from here, if you draw a tangent,
Right.
the tangent and normal, that will be 90 degree.
Yes.
तो ये भी 45 था. If that is 45, then with the horizontal line, this is also 45. Agreed?
Agreed.
This is also 45, this is also 90. So you can figure out like that also. Any doubts on this? Now, same question, you guys give it a try. Same thing. Same mirror. Y is equal to x square. But let's say this time the light ray comes like this and goes off like this. This angle is 120 degrees. Let this point be Q. Find coordinates of Q. Yeah, let's get this. Same thing. Previous one I gave you 90 degrees. Now I gave 120 degrees.
So where should I message you? Like the answer.
Wait, my power
Can
is.
I even message you?
Just give me a minute. The power just came back. I don't know why it is playing with me today.
Sir,
Power
I
is
think
coming.
it's because you came back. That's why.
I came back. The power is playing with me.
Yeah, because you there was a break.
No, I'm more concerned. It shouldn't have happened on the first class of calculus. Like after 3-4 classes would have been fine. I'm more scared about that whether you guys are understanding or not. रुको एक minute. You can just tell me your answer. Tell me.
So I got 1/2√3, comma 1/12.
That looks right.
Okay.
Right, Samyak, you got it. Anyone else got the same answer? Same idea. 1/2√3 by 1/12. Try it another 30 seconds, I'll give. Same thing, draw a normal, draw a tangent. So the whole job is somehow you have to find that angle made by the tangent with the x-axis using your principle of reflection. And then once you got that, you got the slope, then you use calculus. Yeah, someone needs to use washroom or something, you can always go. No need to ask. Go and come back. Yeah, let's see how to do this. Again, listen carefully, everyone, what we're doing. So draw a normal. So this green line here is a normal. Now, because the normal will divide both the angles equally, this piece will be 60 degrees and this piece will be 60 degrees. At this point, if I draw a tangent, I kept it too close. This will be the tangent. And we know the angle between the tangent and the normal is 90 degrees. So this balance angle must be 30 degrees. I hope everyone agrees with that. So if that is 30 degrees, and you can, these are parallel lines, so this angle is also 30 degrees. So basically the tangent is making 30 degrees with the horizontal line. Therefore, slope is tan 30. But we also know from calculus, slope is nothing but dy by dx. And dy by dx is nothing but d by dx of x square is equal to 1 by root 3. This differential is n is equal to 2. It's an x power n ka differential. This will be 2 into x power 2 minus 1 is 1 by root 3. Therefore, 2x is 1 by root 3. X is equal to 1 by 2 root 3. And I know y is equal to x square. This will be 1 by 12. Check your coordinates. Clear with this? Let's see one more like this. Any doubts on this? How did he get the tangent? What did he take the curve? Anything you're not clear, please ask me. Let's see one more. Let's say we have a mirror. Y is equal to sine x. So someone made a mirror in the form of a sine curve. So this point is 0, 0, and this point is pi, 0. So if you put x is equal to pi, sine pi is 0. Same story. Someone sent a light ray like this. It hits the mirror and goes off like this. Let's say this angle is some 60 degrees. Find coordinates of point P. The numbers might be bad. You can just leave it like that, but I get this. How do we approach this? Same story. Draw a normal tangent. Any ideas? Try. I'll give you a minute more.
So the value of cos theta for me is coming as √3, minus √3. So, but that's not possible, right?
Yeah, that shouldn't be possible. I think maybe this light ray is wrong then. I think I gave a long right to it. It should have gone like this. I think I gave something wrong. Theta is wrong. Just change it, make it 120 degrees. Now you'll get it. Let's see. Same story. Draw a normal. See, it doesn't matter what kind of curve I give. The normal will always divide the angles equally. So this angle will be 60. This angle will be 60. End of the day, you just want to find the slope. So from here, if you draw a tangent, this black line is your tangent. This angle would be 30. This angle would be 30 and this angle would be 150. Is that clear, everyone? This angle and this angle, these are the angles, right? 30 and 30. That angle should be 150. Therefore, tangent is making hot angle, so it's making 150. So therefore, the slope of the tangent is tan 150. Agreed with that, everyone? Anyone not clear with angles? But we know from calculus, the slope is nothing but dy by dx. And how much is tan 150? Minus 1 by √3. What is dy by dx? Sin x ka differential. Dy by dx is d of sin x by dx, which is cos x. So therefore, you got cos x is equal to minus 1 by √3. There you can leave the answer like that. Therefore, the coordinate x will be cos inverse minus 1 by root 3. It's not any standard angle, so you can leave it like that. Is this making sense, everyone? This is how applications will come. No one will ask you what is sin x square differential. This is how they'll put that sin x square differential in the question. Everyone clear with this? So there. So we will do more problems like this. I'll send you a small sheet also today. So make sure to practice. So the main thing is, you should know the standard, these differentiations. If you are comfortable with this level, then applications you can see, right? In this problem, what was the most difficult thing? It is to figure out the getting that angle, isn't it? Geometry. Once you got the geometry, the calculus part was actually easy if you see. X square differential is not that tough. So next class when we catch up, we'll continue from here. We will do the level 3 also, chain rule, and we'll do more applications. So make sure to go through the notes. Again, try these problems without seeing. Again, I'm telling you, after every class, you need to revise your notes. And how do you revise the notes? Just don't take the notes and flip the pages. There is a question, take a rough paper, try to solve this question again. Spend 3-4 minutes. That is how you learn. If you just see the question, see the solution, you are doing nothing. So make sure to do that. That will really help you in the next class. Okay, with that, we'll wrap up for the day. Today has been a little messed up also because of this power supply, but I think it is fine. But do make sure to go through this. I'm pretty sure you'll get confused. You'll have doubts. Please don't hesitate. Ask them at least in the next class and get them cleared. Yeah, so that is one. And Arya, bolo now.
Sir, can I ask my doubts?
Patience, Arya, patience. Where am I running away?